In this video, we're going to expand on our 15 by 15 experience to show just why the area model is so powerful as we go forward into later mathematics. The first thing that we saw when we did 15 by 15 is we don't have to limit ourselves to smaller numbers. And the repeated jumps on the number line and the stars and circles models really don't lend themselves to that very well. The second thing that we saw is it's possible to generate a sketch record of action quite quickly as long as we can read what the underlying problem is asking us to do. The underlying problem, to read this again, is to represent a rectangle 15 in one direction by 15 in the other. And when we did that, we found through using our base 10 blocks that it naturally lent itself to the creation of 4 blocks, a 10 plus 5, a 10 plus 5, and that gave us 100, 50, 50, and then 25 in the corner. So when we added all of those together, there's my 100. Here is the 50. Here is the second 50. And here is the 25. And so to find the amount all together, or how many in all, remember that the action how many in all, we smush them together. I did kind of lend it a little easier for us by showing that these two can combine to 100 just to make it a little easier for our counting, although it doesn't have to be that way. But in this case we have 100 plus another 100 plus 25 for a total of 225 square units. Very straightforward. The only thing that we will need to do going forward is to combine these two steps, and we now have the standard algorithm. Now, as we think about a different type of number, I know we haven't talked about fractions and rational numbers yet, but based on your past experience, we should still be able to figure out how to work through this in an action on objects framework. The first thing we do is note that we're building a rectangle. Remember, that's how we're interpreting the multiplication sign. The rectangle is 1.5 in one direction by 1.5 in another direction. And so, taking a clue from how we represented our earlier problem, we can likewise create 4 equal parts. And this is 1 in one direction by 1/2, and I shouldn't have said equal parts, I should have just said 4 parts. Sorry about that. So this is 1.5 from here to here, that's 1 plus 1/2. Here's 1.5 from here to here, 1 plus 1/2. We know that if I have a square that's 1 in one direction by 1 in the other, it's 1 square unit. If I have half a square, I have a half. So that gives me a half here and here. And what do I have if I take that half and cut it into 2 parts? Well, I have a 4th. So I can combine these. I'd have 1 full square. I'd have a half square. I'd have another half square. I'd have a quarter square. And half and half combines to make 1. So I have 1 plus another one is 2 plus this 4th in the corner. Let's try something else now. Let's try 1.5 times 1.5. I think you can start seeing what's going to happen here. I'm not going to belabor it over much, but again, we're going to create 4 parts. We're going to have 1 plus a 0.5, 1 plus a 0.5. And how big is this? Well, 1 times 1 is still 1. 0.5 times 1, since 1 times anything is just that many, is 0.5. And there's another 0.5. And how big would be 0.5 times 0.5? Well, it's 0.25. And right now I'm going to say you can check it on your calculator, but when we cover fractions and whole numbers and decimals, it'll make a little bit easier sense. In any case, we add them up now. We have 1, we have 0.5, we have 0.5, we have 0.25. 0.5 and 0.5 combine to make 1. So I have 1, 2, 2.25. Look what we've got. Almost the identical picture can be used to represent each of these number types. And this is something unique to the area model. Repeated addition on a number line will not give you this ability to generalize. And the stars and circles model will not give you this ability to generalize. What the whole number representation shows us is that we can use our base 10 blocks to easily model it. When we get into fractions, we're going to be using sketches, and clearly this is a fraction we're showing here. When we use fractions, we'll be using sketching. So this is Ardine's block, Ardine's base 10. Fractions we'll be using sketching. You'll also notice when we get to decimal, we can present decimal with sketching also. Now, the sketches draw their power from our earlier experience with the whole number representation using the Dean's blocks. And because our sketches for the record of action look identical, we can parallel the process in each case. So what we see is we see an identical process that plays out across each of these number types, which is extremely powerful. Now, to bring it home even further, let's take a very abstract case where we have something that maybe is x in one direction plus 4 and x in the other direction plus 6. Well, how big is this? It's x times x. So that's x squared. This is 4 times x. That gives me my 4x's. And there is 6 times x, which gives me 6x's. And we have 24 in the corner. So just for grins and giggles, we can represent that like this. When we add them up, we have x squared plus 10x plus 24. And you notice that we really did not even need to use FOIL because we had a better representation in place. This ability to go up and down the abstraction level between whole numbers, fractional numbers, decimal numbers, and abstracted numbers, which is what a variable is unique to the area model and is why we keep pushing for our students to come to a full understanding of the area model, because once we hit the level of representation shown by this sketch, the processing steps become identical. We just look at each of the 4 sections and we smush them together, and that'll give us our final answer.